Good afternoon. Hi, welcome to our very first DevOps meetup that we are hosting as GeekyAnts, right? So to start off with, I am Vasukivardhan. I'll be hosting this event for you this evening. I'm currently working as a tech lead over here, and I work from all the things from front end, back end, and platforms and everything in between, right? So that is just a brief about myself, and probably we can catch up sometime later post this event, right? To start off with, to give you a brief introduction of GeekyAnts, right? So we are basically a product studio. So we have built out a lot of products on our own. We have built out a lot of products in collaborations, right? So a lot of you might recognize us via native base. Right? That's one of our React Native frameworks that we have built on open source, right? So, and also we have done a lot of contributions to React Native. You will find a lot of GeekyAnts people in the React Native contributors list, right? So we actively contribute into a lot of other communities. We contribute to React, React Native, Flutter, and a lot of other things, right? So, and also we attend a lot of conferences. You will find and meet people of GeekyAnts speaking or just even attending the events all over the country and also a few international, right? So that gives us a lot of experience on hosting our own conferences like the ones that we are having right now, right? So we host a lot of other meetups. So we have hosted meetups of AI, React Native, Flutter, design meetups, and all those things, right? So, and this is our, as I said, this is our first DevOps meetup, right? And we also hold a lot of other community activities. We do a lot in terms of organizing other collaborative things, right? We do things in React communities. We also are currently involving a lot of our efforts into other open source communities, right? So things like OpenAbilla and other things on the DevOps side of things. And we also have a lot of upcoming and already available partnerships that we have, right? So we abundantly work with Vercel, Hasura, GitHub, and a lot of other things. Probably will give you a bit more information through the keynote, right? And if you want to guys want to connect into the internet, and if you have any other issues, you can directly connect to our Wi-Fi, GeekyAnts guest, and this would be your password. You can just snap a picture, or you can just connect it right away, right? So having said that, so we have a bit of code of conduct when we do host these meetups, right? So probably keep your language into more professional or casual way, right? So the way you would address your friends, right? You're yet another friend. You can probably use that language and not the ones that you use with your close friends, right? So you can talk to a lot of people over here, and everyone probably will find the badges that they're putting out, that you can just go ahead and introduce yourself, figure out what they're working on, what they're interested in, what you're interested in, and probably can build your own network over here, right? And across the meetup, you can keep your questions to the panel discussion, right? But if there are any gaps that we have in between, probably we might take one or two questions, but we would encourage you to note down or keep your points back to the panel discussion, right? At the end, we can probably we'll open up the stage to all of our speakers and all of our audience. So you can probably bring up your questions or your discussion points to that level. Okay. And also try to keep your internal discussions to a bit minimum. I know a lot of times when you're looking through the slides or interacting with the speaker, probably you might remember or find something that might interest you that you would want to share with other people. You can go ahead and still do that, but try to keep that to a minimum, right? And also, if possible, please keep your phones on silent, right? so that it doesn't become a bit distracting for the speaker, right? So yeah, let's get started. So we have our first speaker, who's our own ADOE over here, Fayaz. Right, he will be giving you an introduction to the meetup, right, and will be taking you through the entire keynote of the meetup, right. So over to you.
Hello. Hello, everyone. My name is Faz. Thank you, Vasuki. Let me just see. We have the slides. Right. All right. So, my name is Faz. I work here as Associate Director of Engineering in GeekyAnts. Right. We have, like, as Vasuki told, we have been having lots of like different kinds of meetup in GeekyAnts. Like technology specific, I would say, like React Native. Onto the backend side, we have done different things. But this is our first meetup for DevOps. Right. So we are excited and we are bit, I would say, nervous about it. So let's get to it. Like before we start off with this thing, can anyone just explain me like how would you define a DevOps? Like, is there a definition that you guys know, or if you have to explain it to somebody who doesn't understand DevOps, what would you say? Yeah, man.
Sir, DevOps is a sir DevOps is a sir DevOps is a drive from sir two words, sir, dev plus operation, मतलब development plus operation. Sir, where we can sir one side we can develop the codes and second side the operations, which means the developers write the code or they built it and it performs in the servers.
All right, cool. Anyone feel like adding something to it? All right. I have a definition prepared for you guys. So DevOps, I think, is a culture and is a technical movement actually, right? Which basically is trying to like bridge a gap between developers and the operations team. So the thing is like DevOps does is DevOps will automate the processes for software development as well as IT operation teams, where you don't have to like specifically reach out to our IT operations guy or a software developer guy to like bridge like to discuss about a specific deployment or something like that. So this is what I feel like is a definition for DevOps. So yeah, that's it. So as I said earlier, like it's a collaboration, it's a communication and an integration. When it comes to like cross function, like cross team discussion, we all know like we have a bit of something where like we miss out or misunderstand or something bad happens and it might affect our production applications or different kinds of like environments. So that's what DevOps does for us. Like it provides you a platform where you can collaborate, communicate, and integrate different things. So this is the core principle where DevOps will automate, it will provide you a continuous integration, and it will also give you a continuous deployment process, right? So that's all DevOps is. If it is come to like drill down to a specific 2 to 3 words, I would say automation, CI, and CD. That's what DevOps is. So now we will say, see what is the evaluation, how DevOps has evaluated in the time. Like I remember, like in 2000s, I would say this agile development came into the picture. So does anyone know like what is agile development? Like use my
I mean, in simple layman words, it means continuous improvement of a product at any time. Keep
yeah.
iteration of the product. So,
Yeah, that's correct. Like it provided us like a strategy to really create like minor and major releases of our applications, right? So that's what agile development did. But in mid, I would say 2002, 2005, CI came into the picture where it started providing us an option to like integrate our agile development. So agile development was just like you develop and test and then release, which was still a manual process by then. There was a strategy, but there was no automation provided. So CI came into the picture, the rise of CI. So again, I just want to interact with you guys. So anyone, CI, what is CI? Yeah, speak up. That's totally all right, man. Anyone? All right, cool. No worries. So CI is basically like integration. Let's say we have a product and the developer has pushed something, right? And now we want to test all those things, but we do not want to like bother somebody to like test all those things. So we automate and provide a platform like a strategy called CI, where we will just push into a pipeline and it will test whether this is a releasable product, whether we can like proceed with this and stuff like this, right? So basically, like you will have a QA or you can have a continuous integration pipeline. Then came into the picture development. Now, since we have an agile development process, we have a continuous integration process. Why not build something which will also deploy, right? Why wait till CI? Like, why aren't there? So CD came into the picture, continuous development, and there's one more thing. Well, it was like continuous delivery. So continuous development was like just another way of deploying a project. Now, still CI, we were not deploying our project. We were like doing a manual process of deployment. It was just that we were like looking at the statuses of integration, and if it was fine, depending upon the strategies and everything, people were deploying the project manually. So continuous development came into the picture. People started using continuous development pipeline. There are lots of tools available right now. Can you people like tell me what are the CD tools that you guys are using right now? Jenkins, Ansible, okay, Ansible. Cool. Yeah, it is a way. All right, let's move on. Now, since we have CI, CD, so basically we have a total automation pipeline available where software developer would just push, and internally our automation pipeline will test, it will deploy, right? So we have a like I think in 2010 microservices architecture came into like it came into the picture. Lots of people were using microservices architecture where the thing was like you can like deploy small services on a different server and use them as a single front using an API gateway or ingress controller, something like that, right? So microservices came, and along with microservices, so like the need for CI/CD started emerging more. Like people were like more interested in using microservices architecture, and this is why like DevOps came in. Like DevOps was in the picture now. Developers were interested in DevOps. So I think microservices has given our DevOps culture. But DevOps, I would say, for DevOps, sorry, I'm nervous a bit. So if microservices actually gave us like a way to use CI/CD pipelines. So people started understanding and knowing about DevOps. What is DevOps? Because before like all these things, this IT operations was like way too typical, and people were like most of the developers avoided. Still, we have some people who will avoid, but now we have like a proper DevOps culture, containerization and orchestration. So in 2000, I guess 11 or 12, Docker announced containerization and orchestration. Containerization was nothing but like you can put up a microservice or an application you in a container and host that container on a server, right? So stuff like containerization or orchestration came into the picture. For orchestration, has anyone used anything beyond Kubernetes? Anyone? Cool. So now since we have all these things, DevOps and cloud computing, they started like working together like DevOps. We have cloud computings where you can buy cloud servers, which are basically it could be a virtual private server or virtual private server, or it could be a bare metal server, but it can reside on a cloud servers. Then we have now see we are seeing AI and ML, right? There's after ChatGPT has announced like there are lots of softwares and tools. People are now utilizing AI and ML, and the DevOps teams has also started evaluating and seeing how we can improve our DevOps using AI and ML. Like I would give you an example, like depending upon the score of CI, let's say I have a Sonar cube server, right, integrated, and if it gives me 75 to 80%, and depending upon the type of errors or warnings that I have got, I can like use AI to understand all those things and send me a proper report what went wrong, or if it is good to deploy. And then if we have like properly deployed machine learnings and everything, then we can also let it decide whether it want to deploy the server for our users or not. So that's how the DevOps has evaluated. Uh, the evolution of DevOps has happened from like from my perspective. So yeah, that's it. So how GeekyAnts is taking part in it, as I told you earlier, like we have lots of things. Like we have been like doing when it comes to containerization or orchestration, we are using Docker and Kubernetes purely. Like we have used like mostly all the applications are now Dockerized, and we for orchestration of these containers we mostly go with Kubernetes. For automating CI and CD pipelines, we have Jenkins, we have GitLab CI, we have self-hosted GitLab CI actually at GeekyAnts. So we use that. We have Bitbucket CI, GitHub Workflows, and Vercel. Vercel is basically a tool which would just like you don't have to define anything. It would just ask you to connect your version control and it internally manages everything. But since it is a CI/CD pipeline, we have mentioned it here. And then for infrastructure as a code, we are using Terraform, Ansible, Puppet, and Chef. And for monitoring and logging, the basics Prometheus and Grafana and ELK stack. Then for deploying we have AWS, Azure, GCP, DigitalOcean, and OpenNebula. Does anyone know what is OpenNebula? Yeah. So what it does, like if you have to explain it in a layman terms of for others. All right. So anyone else that would like to add? Pratik, I see you here. No, go ahead. Yeah, so we like GeekyAnts is now working like using OpenNebula. We have our in-house data center, and we are using OpenNebula to create our virtual servers, and these virtual servers are getting deployed. So that's what OpenNebula is doing for us. And as I told you, like we are planning on like creating our own data centers. Pratik is our managing director, and he's working on it since a long time now. So there's that. Apart from all these things, is there anything that you guys would like to add? Like it should be here, but I haven't read it. This is what GeekyAnts is using it right now. But any service, yeah, man. Heroku, yeah. Yeah, actually. Thank you for pointing out. All right, so yeah, Heroku as well. Anything else? Yeah, SonarCube is like a CI. Yeah, we can say it does. Anything else? Sorry, Sona, can you give him his mic? I can't.
Argo CD.
Arco CD. All right, I haven't heard about it.
Ah,
What is it?
it's a CI/CD pipeline.
All right, cool.
Yeah.
All right, so is it an open source tool or like?
Yes.
All right, cool. Acha, I haven't like heard about it, so I had to know about it. Cool, man. All right, so this is like we have we are partnering with a lot of companies now. We can so Versal is one of them. So we have a collaboration with Versal, Hasura, and GitHub, right? So I will go back to Versal. Versal is basically now has become an ecosystem. Previously, it was just a Next.js technology. Like they were using Next.js. It was an open source. You can create your React applications, and there was a way to provide you like server-side rendering of your React components, right? So basically, you can like send your React components from the server side onto the browser. So, but now Vercel has evolved, and they have now an entire infrastructure where they also provide CI/CD pipelines, where you don't have to do anything, just integrate your project with the GitHub, and it will automatically deploy, right? So we are using it Vercel, and we are now like in partnership with Vercel as well. Hasura. Has anyone heard about Hasura here? Cool. How would you explain it? Yeah.
So, so if you have a say a Postgres database with and Hasura is basically like something you can put in front of your DB that'll automatically generate and like you can almost like a GraphQL API for you to directly interface with your DB itself. Yeah.
Yeah. So basically, Hasura, as he explained, like Hasura is basically a middle platform. I would say not a middleware, which basically when you create a table using Hasura's platform or a console, it will create that table into the Postgres, but it will provide you GraphQL endpoints for those tables as well. So basically, you have avoided creating APIs or GraphQL APIs for your table, right? So that's what Hasura does. The Hasura also comes with an enterprise solution where they provide some optimizations, but most of the stuffs are open source. So we are collaborating with the Hasura. We are sponsoring them, and then we have GitHub. So we our all open source projects are on GitHub, and we are now like in partnership with GitHub as well. I think most of us now know GitHub, so I don't have to ask it. No, we are using enterprise for us like private repositories, but mostly like all open source projects are used like on GitHub. All right, let's see like what we have scheduled here. So we have like I think sequence has been like changed. So I will just tell you like we have Srinivas Gowda, and he's gonna like you can read it. They're setting up a home lab, like from bare metal to a fully functional server. So he's gonna like enlighten us on that topic. Then we have Robin Biju Thomas. He's gonna like talk about things developer needs to know about DevOps. I think Robin would go first, then Srinivas would go after Robin. And then we have Kuldeep Pisda, who is going to talk about securing web-based applications on platform with proper response headers. So there's that. Then we have Aditya Prakash, and he is going to talk about deploying an application to Firecracker micro VM infra, right? So that's what we have planned right now. So let's get to it. Yeah, that's all. Thank you, guys.
Thank you. Can you have a huge round of applause for Faz, please? Right. So next start off with, we'll be having Robin here back on stage. So he's a tech architect from IoT5, right? So he'll be talking to us about what all you need to know as developers to understand DevOps, right? Or give you a sneak peek into what DevOps is, it, from a developer's perspective. Since DevOps stands for developer operations, it we thought it would be a great topic to start off with, right? So handing over the mic to Robin. Please welcome him on stage, please.
Am I audible? Just a second. Okay. So thank you everyone for being here on a Saturday afternoon, especially with the current weather. I think the turnout is quite great. I'm here for a very basic talk. Since this is under the banner of React Native, I anticipate there's going to be a lot of developers here. So this is just to give you a very brief overview of DevOps and certain DevOps terminology that can help you streamline workflows in your day-to-day jobs. So just to get a feel of the audience here, how many of you are, say, front-end developers? Back-end? Full stack? And DevOps professionals? Okay, yeah, that's more or less what was expected. So I think we are good here. So let me just give a very quick introduction of myself. I'm Robin. There are a few familiar faces here from past meetups. It's good to see you. I am a technical architect at IoTify. I also like to describe myself as a deep stack engineer or a generalist, for the lack of a better term. I generally, because we are a startup, IoTify is a startup based in Switzerland, we are entirely remote workforce. So we work on IoT testing. That's the primary product. But since it's a startup, um, the scope of each person is quite varied. So I often handle the design, development, deployment, and debugging of several features. So that comes with a certain degree of visibility. And as I have interacted with developers and DevOps professionals, there are even though the common objective is to get your features out in the most efficient manner possible, I feel that there can be a bit of cross domain knowledge that we can cultivate to streamline the flow, because the there can exist certain gaps in an organization that we can better bridge. So this is the standard diagram of a DevOps cycle, right? When one thinks of DevOps, this is immediately what comes to mind. So this is your say your create, plan, release, monitor, configure, package, verify, right? Your standard DevOps cycle. So developers essentially approach this from the create standpoint, as in their priority is in a very agile manner, get the feature out the door. Otherwise, the manager starts screaming at them, right? So think of that from the development manager's perspective as well. So two structures within the org. So priorities are slightly different. So from the as far as the operational point of view, say some test failed, or as it went into deployment, some part of it required some extra troubleshooting or some stability. So DevOps people are first to try an approach to put out the fire, right? So that's where their visibility comes in. As in, you guys can put your feature out of the door, but in the end, if the production breaks, I'm gonna get yelled at first, right? So think of think of the different perspective that's coming up here. Also, in talks of there was a very great introduction to DevOps right before I walked onto stage. So just to add to that, let's say my definition of DevOps, I was just saving it for my talk. I would say that DevOps engineers do anything that facilitates a developer. So anything to make the developers or the release cycle easier, that comes under the scope of that comes under this. Now that field itself has evolved into, say, platform engineering, SRE, core DevOps, all of that. But a simple and I would say rather a, dare I say, poetic way of looking at things is my job is to, or rather the job of a DevOps person is to make the developer's job easier. Now you might find that quite contradictory whenever you ask for a separate developer environment for each project. They can come back to you and complaining that we don't have that in the budget. But then again, there are priorities that are different. So let's try to address the problem here, at risk of stating the obvious. The skill sets are quite diverse, right? DevOps people spend a considerable amount of time in let's say YAML or Python for a lot of automation, let's say. So fundamentally, when you talk from a programming language point of view, the skill sets are slightly different, as well as expertise. Their expertise is more centered towards root cause analysis, finding what is breaking, ensuring stability, anticipating issues that can happen in production, prioritizing, reducing risk, finding out plans for rollbacks. This is generally the skill set that a DevOps professional would bring to the picture. Whereas from a developer point of view, again, your priority is agile development, right? So you might use the latest bleeding edge feature that just got released and that has let's say React server rendering, or let's say some kind of a new VPN technology that, or something that requires inbound connections. When I say inbound connections, I mean changes in network parameters and things like that. So you as a developer are tuned towards bringing in the latest technology, finding the best and the fastest way to solve the problem. So again, those are your different skill sets, different priorities, different perspectives, and different contexts. So DevOps people generally operate within the context of security is one thing. If there's a breach in the infrastructure, so let's say you have a new feature that exposes a network port, so something that requires an incoming connection to your server, or something that requires a connection to persist, or something that requires you to expose multiple ports or channels within your server. All of these are concerns from a DevOps point of view. So this is the cliche meme that comes up whenever you talk about containerization or virtualization or even DevOps, right? Something happens in production, you get a, say, a rollback happens, and then you approach the developer. Either the tester or the DevOps person approaches the developer, saying what's going on, and then you say it works on my machine. So in the call for proposal of this talk, I basically mentioned this is the usual dialogue. So let's talk about your machine. And what we are going to do today is come across or cover some basic topics that will help you communicate better. Um, Again, my PowerPoint will not have definitions or a lot of dense information. It's just a visual tool to keep me on track. Otherwise, I can go on tangents. So the intention of this talk is to get you familiar with some terms and terminology that they might talk of, jargons, or let's say again, context that will help you anticipate or understand their issues much easier, and you know, troubleshoot and get stuff out of the door much faster and much more effective. um, Also, I think a lot of this can be addressed by building a bit of cross domain knowledge. Of course, we have very busy work schedules, and uh, 8 hours in a workday is sometimes not enough. So I'm actually quite happy that there's a talk coming up about home labs that will actually help you with some of this learning aspect of things, wherein you can tinker some of this out yourself and get a better understanding of things. So whether it is a CI/CD pipeline, is it okay? Okay. So whether it's a CI/CD pipeline or whether it is a Kubernetes cluster, right now there are very easy things that you can spin it up yourself, get a feel of things. And as a programmer, you might not be very aware of where your code is getting executed. So you get a better understanding of that operational context or that deployment context when you try some of the yourself. So that's one that's some of the things that you can do to make things a bit better here. A few terms in this space that we can quickly glance over. I initially had a plan to show you a basic GitHub Actions workflow, but for the sake of time, we'll leave that for a future meetup. Containerization. In anybody aware of what containerization means apart from the DevOps guys, the engineers, I guess? Anybody who doesn't know what containerization is? Okay. So uh, coming back to this meme, there's another version of this meme which says, then we'll ship your machine. That in essence is, if it works on your machine, we'll ship your machine. So what containerization essentially entails is you take your code, you take your runtime, as in, let's take Node.js, for example. So what is Node.js? It's a runtime, right? It's not a language, it's a runtime. So Node.js has several different versions. Each version has a particular feature set. Let's say some new feature was introduced in the latest LTS, let's say 18. So when a DevOps person asks you, how do you run your program? Your answer is not to click the play button in the IDE. It is your npm run start or npm run build or something, whatever you have put in your package JSON, right? So that apart from that, what all environment variables do you need to set? Certain aspects of your application would be so I'm covering a couple of topics here. This includes, say, configuration management, runtime, etc. So some aspects of your application may be configurable, right? And you have a couple of ways to do that. Either fetch it from a remote repository, instantiate it, or simplest way that we tend to do things is environment variables. So before running your application, what environment variables need to be set? How do you, are there any particular other connections or network ports that need to be opened up? All of this comes under your execution context. And all of this context, say, when you started developing your application or when you set up your dev environment, maybe you would have had, for example, this is a very niche use case, but if you have something monitoring the file system, there is a certain flag in the Linux operating system that you need to set to ensure that above the number of files that are visible to the watchdog for changes. This is a very niche application. You would have come across that error when you were developing, and you would have fixed it, and then you would have forgotten about it. Now feature is developed, it goes to production, and say this is not written down or documented in your execution context. That is definitely going to break in your build pipeline. So your runtime, your configuration management, all of this comes on all of this. you need to essentially document it. Easiest way is ensure that your application is containerizable. So you write something. Right now the de facto technology is Docker. So you write something called a Docker file. So how you can set up your application in a basic, assume that you just finished a fresh install of Ubuntu, or let's say a basic Linux. How can you get your application up and running in that context is what you need to keep track of. Any even however minute it might be, any change that you make to that context needs to be noted down, that needs to be taken care of. And you can even get it done, get it up and running with something called Docker Compose, to ensure that all of your environment variables are accounted for and everything. Feature toggling. So this is again needs to be, this is again intersection of say developer and DevOps. This needs some planning from the DevOps side as well during when your feature is being implemented. So say you do a giant release, or with you do a mainline release or a beta testing release of your particular feature. Sometimes you don't want it to be toggled for everyone, or you do not want it to be toggled all the time. A good example of this is your Instagram UI. Every time I try to share something with someone, the share button keeps jumping around. The UI changes quite often. So this concept is called feature toggling, or remote configuration management. It essentially means that the runtime configuration can be fetched from an external source. Either that could be from a database like DynamoDB, or you can have that as a parameter within your database, or you can have something called AWS app config and then fetch the configuration from there. Running a bit short of time, so I'm going to go a bit faster. Please stop me if you need a bit more visibility. We have a panel discussion as well for answering your questions further. Open telemetry is a very interesting field these days. So a lot of us, a quick and dirty way of doing logging or monitoring is console.log, right? And we might even use something like Winston, or let's say even Datadog clients to get insight into what's happening during the runtime. Another standard that's coming up in this field is open telemetry, so that you can you can have a plug and play ecosystem in terms of, let's say you use Grafana Loki or some other kind of log aggregator. It essentially specifies a standard in which you can record logs, as in capture logs, as well as have a tracing. So if something breaks, it happened by this instance of this microservice running on this node. So you get a full trace of where the error happened. Immutable infrastructure is essentially goes along with this infrastructure as code perspective. So if you have one flavor or distribution of Linux, or if you have one kind of environment, the same is used in production, the same is used in staging, the same is used in testing, and sometimes the same is used in development. Chaos testing, this is something that was pioneered by Netflix. It's essentially where you try to break things in your staging itself, so that you have better visibility into what happens when something breaks in production, and you can plan and budget and account for it. Scaling, so whether your application is horizontally scalable or vertically scalable, as in do you just throw more memory and CPU at one process, or can you have different replicas of that process? That can sound quite simple, but there are design considerations you need to do as a developer, or as an architect, or as a senior developer, whoever is making those decisions, to ensure that if another instance of your application comes in, it has its own identity and it doesn't try to replicate your database connections. There is queuing happening, and you don't run into race conditions. Optimizations as a developer, some things that you can be aware of. Like I mentioned, note down every change that you do to get your application up and running. That's called a replicable build process. In the DevOps side of things, you try to automate as much as possible. One of the best things that we did when we started the rebuild of our products was we set up a very automated build pipeline. So that particular thing was with Atlassian and your AWS code build and stuff, but you can do the same thing with Jenkins or Argo CD, essentially. So the whole fact of the matter is, if it's not replicable, it's very tough to automate it. just like how a user or a tester reports a bug without the steps to replicate it, right? You can't act on that information very well. Anticipating some common issues, for example, things that could break because of, let's say, changes, possible race conditions that can happen. So, in your development environment, say your database is always up and running, but say you're bringing up a cluster. Um, are there going to be race conditions? What if the application comes online before the database container or whatever comes online? You need to consider those edge conditions. Otherwise, those are basically issues that are waiting to happen. It might not happen in most cases, or you might have a priority setting, but it's one bad day away from happening, and that'll happen at the worst of times. So some things you can anticipate from yourself. So it's again a perspective switching, right? um, think of how your application is going to run or how your feature is going to run, and understanding environments. We covered a bit of this earlier as well, in the context of getting together your runtime, your configuration, your environment variables, and all of that. The cloud native way. So right now we are heavily in a microservices kind of a domain, right? So infrastructure as a service being one, platforms, software as a service, and now there's even function as a service paradigms. So in between all of this, one of the most commonly adapted paradigms is the Docker file. So if you're having in a microservice model, or if you want to basically run anything on Kubernetes, there are options like Knative where you can essentially run a VM there, but um, anything that's basically asking for tech debt to be accrued. Instead, if you, as you write your application, if you can get a Docker file and a Docker Compose file written along with it, it will make your life and the lives of your operations people down the line much more easier. And again, this will allow you to ensure that your code can run on a vanilla JS or a, sorry, vanilla Linux distribution. Vanilla as in nothing else has been installed at that time. Containerized dev environments. Now this can go a bit haywire. So there are some debates about whether you should use Docker Compose for your dev environments or Kubernetes for your dev environments. It's very much possible there are lightweight distributions of Kubernetes, but if your deployment is going to be running there, there are certain considerations, or there's something to be said for a dev environment also that is containerized. Scaling considerations, we already covered how to manage configurations. Let's say HashiCorp Vault, or if you're using Nomad, you have a HashiCorp Vault, or if you're using, say, Kubernetes, you can have a configuration within Kubernetes or other third-party situations. I think that's a very brief overview. I feels a bit rushed, to be honest, but I hope that it had a slight takeaway for most of you at least, or if you learn something new in some capacity that helps you with your daily operational context, I could say, as a developer. So yeah, thank you.
Yeah. On. Yeah. Hello. That was a pretty insightful talk, I guess. Right. So probably that would have given you a bit more perspective into how things work in DevOps and how you can look into each and every of your programming stacks in terms of uh, an operations perspective, right? So coming up next is Srinivas, right? So he'll be presenting us his setup of home lab. So he'll be taking through on how he set up things, what are all the things that he used, and all the things in and around it, right? So this would be pretty interesting. You would have tried to set up your own lab at some point of time, right? it's probably an interest peak during your college days or during your experimentation days, right? So this is something that would give you a bit more idea into how you could do it and what all things you could do in and around it, right? So we'll be handing over the mic to Srinivas. Please welcome him on stage.
Check. Hi, guys. Again, thank you so much for joining on a Saturday. We don't get enough credit for getting up on a Saturday morning and coming out for a meetup, right? So, yeah, thank you for that. So, my talk is sort of like a part two series of something I had spoken about last year at FOSS, where I was just beginning to put together this home server of mine. I mostly covered how to set the system up, using RAID servers and LVM and stuff like that. But from then on, I've kind of moved, a few things, and I've configured a couple of stuff. So I thought I'll just put that together and maybe, have a part two series of that talk. So having said that, the agenda is mostly to cover what kind of hardware configuration, minimum hardware configuration for setting up a home lab server, what kind of a software stack that you would want to set up, which would allow you to kind of, you would want to extend on top of it. It's not like you would just install it and forget about it. You want to keep upgrading it and you want to keep adding more hardware to it. So keeping that in mind. Networking and reverse proxy, probably one of the most important aspects of running a home lab server. Security coming in, because you're letting if you want to host your sites and services publicly, you're just putting your network out there, right? Port forwarding and all of that stuff. So I'm going to cover a bit of how to secure that. Some security measures on the Linux stack itself, containerization and all that good stuff. Exploring possible use cases, like there are tons of use cases that you could probably cover with the home lab server. Some of my favorite I'm going to cover, something that I'm also working on. So why set up a home lab server, right? A couple of good, whys over there, and let me kind of give you my why, right? I want the ability to use FOSS in my daily life. I grew up in Bangalore, and I've been using open source software for all my life. I've probably made a living out of it. Probably most of us have made a living out of it, right? So I really have a lot of love towards FOSS. I want to use it in my daily life as well, not just my professional work life. So, and it's really fun if you're a hobbyist programmer, right? You want to tinker with hardware. Now, just that we all have met on a Saturday morning, coming out after like a Monday to Friday slogging, work, and then you come on a Saturday, just shows how much of hobbyist hacker mentality we all have, and it just kind of helps, nurture that, right? And setting up, the third point is probably the most important. You sort of have this mental construct of how a public cloud works, and you kind of get used to it. I'll give you a simple example. Let's say there's an engineering student who kind of just passes out, and he's trying to get a job in IT, and then he ends up working for a startup, fairly doing decent. He starts learning programming and everything, and then one day his manager comes up and says, "You know what? Let's try using Lambda functions, okay?" And this poor guy does not even know much about how a server works. Now you're putting him on something serverless, right? And what happens? He obviously has to connect to a database. He connects to an RDS. He's not able to connect. He goes up to his manager, or anyone who knows a little bit of DevOps, and he understands, okay, so I have to put this thing in a VPC. He puts that stuff in a VPC. He's able to connect to the database, but then he realizes he's not able to connect to the internet now, because you put a Lambda in a VPC, it loses internet connection. Now he goes back Googling, and he finds out you need to route your tables, you need to add a NAT gateway, you need to subnet, and this guy doesn't know how to subnet on his home computer. You are asking him to do a CIDR classes internet domain routing. Gets ridiculous over there, right? So yeah, all of that stuff, somehow he kind of manages to kind of do everything. And then he realizes this Lambda is not working quite properly. It keeps stopping. It's slow. So he figures out there's something called as a cold start on Lambda, right? So you see the series of stuff that's happening. You put someone on a public cloud with that mental construct. You don't have the basics, right? And then you expect him to run this thing. Doesn't really work, right? And then he realizes that you need to put something as a warmer, right? You need to warm the Lambda up 5 minutes for without VPC, 15 for with VPC, right? All that kind of stuff. So all this kind of goes away if you have a basic understanding of how a normal server works, right? What's a server? Just a computer that's connected to the internet with some security measures, right? So fourth point is data control, having the ability to control every aspect of your data. You have your Google photos, you have your Apple photos, which costs a lot more than what an S3 bucket costs, right? You all know that it's expensive. They're ripping you off, but you can't do anything about it. Well, you can have a home lab server and probably set up something on your Android or your iPhone that can probably sync, and probably don't have to pay all that money. So coming to the hardware part, I did a bit of experimenting. My first, like everybody else, right? My first try at a home lab server was probably a Raspberry Pi. Trying to run everything on that ARM CPU. But from there on, I understood that I need some more juice in the system. So the minimum hardware configuration is probably have a multi-core CPU, a DD4 RAM, have an SSD for your boot, and HDD for all your storage, and then have a router with a good port forwarding support and a firewall configuration. Ideally, you would want to go with something like pfSense or OpenWRT, but a decent router should also be fine, right? If you want to just do port forwarding and have some firewalls there. A minimum connection of 20 Mbps should be decent enough. A really good heat sink. I can't stress enough on the heat sink part. Bangalore does get really hot at some point, right? And you investing in a good heat sink and a good fan which is silent will not only give your computer good cooling, but also peace at night, because you don't want that fan going all that night, right? It just irritates you. Probably just turn it off. So my server configuration, I picked something decent. I picked a Ryzen 5 3500 CPU with 6 cores, gigabyte motherboard. I wanted something which I could upgrade and not spend too much on. I settled for a 16 GB RAM because I wasn't sure what I was going to do with it. I went with an NVMe 256 RAM for booting my OS, and I invested in a Coolmaster Hyper 410R, which is a really nice heatsink, right? And I have a 1 TB SATA HDD and a 300 Mbps connection that I also use for my work. It's not just exclusive to the home lab server. And the final build looks something like this. It's quite compact. The idea was to kind of be able to kind of open it up whenever I wanted to, kind of, get the dust off, or maybe add more disk to it. And the Raspberry Pi you see on top is actually a Pi hole that does DNS filtering for me, right? That's basically the setup. It's quite silent. I made sure that the fans do not kind of make a lot of noise. Yeah. So coming to the software bit, I put a lot of thought into what I wanted. It was very tempting to just install Nginx and just have everything right on the Ubuntu server. Now I have a RAID set up with an LVM. I run Ubuntu 22.04 on it. Right. I did not go with Proxmox because I wanted something simple and standalone. I went with Docker because I'll get to the bit why I went with Docker. Then I wanted something to manage my Docker. I didn't want to always go into the terminal and just manage my entire thing, right? Portainer did a lot of wonders, right? I was able to kind of quickly test out this Dockerized softwares, and I was able to destroy them quickly. It was nice. It was clean. Made me feel good. Because it's not like I install something and just forget about it. I know I can easily get rid of it. So easy that way. I did start off with Traffic, a layer 7 proxy, but then I realized it was such an overkill for me. I settled with something called the Nginx Reverse Proxy Manager, which has a really nice web interface and does SSL and all of that good stuff. So I just settled for that. UFW and fail to ban for firewall on the Linux system. I'll get to the part where I do firewall outside the stuff. And Tailscale, because I wanted to connect to my home server if I was away from it. For instance, if I want to give a demo right now, I could just connect to Tailscale and show you how my Portainer works. But that's only accessible once I get into Portainer. So that was pretty cool. And benefits of using Docker container, right? Universally compatible. It can function correctly on all major Linux distributions. You don't have to worry the underlying host Linux system. It could be running something old, but it could be running something bleeding edge on the Docker itself, right? Separation of the files, service file systems, right? It doesn't kind of just clutter all your installation files and everything everywhere. And simplicity of removal. Easily kind of just get rid of the data volume and images, and you're back to doing what you were doing, right? So yeah, and the again, entire dependency daemon and everything gets bundled into one Docker image. You can have your own Docker container registry and pull from there as well. Portainer has really good support for that. Doesn't stomp all over your file system servers again. Can't stress enough about it. Like days when you had to kind of just install stuff from source, or deb files and things like that. This is like a major step up. So networking part, put a lot of thought into it because putting your services out there, it's kind of risky. You're letting people in your home, and people will find out if you put your stuff on your DNS, right? There are a lot of hackers who want to just mess with you. If you have a domain, it's easy to kind of look up your DNS and see what your IP address, and they try to ping. So two options you could go with. The first option is self-hosted with a VPN. If you look at this, you have a firewall, you have a subnet, which kind of separates your server with the other devices that you connect on your network. So get a decent subnetting in, and you have a VPN like Tailscale, and only people who have access to the VPN will be able to connect to your services. So that's fairly easy to get started with if you don't want to kind of put your services out there, right? Tailscale is a really good setup. It's almost like zero configuration. You just have to install Tailscale on your machine, and it just does things magically. The UI is also pretty good. They have an Android client, they have a Mac, a Linux client works really nice. It works on top of WireGuard, and especially Tailscale is built on top of WireGuard Go, which is even more lightweight and performant. The minute you install Tailscale VPN, you have remote access by default. You have an exit node where encrypted traffic and all of that gets to the final destination, right? And you can have something called as a subnet router. If you don't want to connect all your devices in your, at your home, but you want to still connect to them through you can have a subnet router configuration where you can talk to other devices in your network, having one device connected to Tailscale. Second option is what I went with. I mostly went with the hybrid option where I have Tailscale, I have some services which I only have access with. If I connect to the VPN, then I have another set of services which I expose to the public, right? So this is the setup that I have. What you see over here is, on top of the on the cloud, I have Cloudflare DNS configured with proxy. So that's my start point. All my DNS is managed through Cloudflare, which gives me all this free stuff, managing my proxy and stuff, gives me extra security. Then I have my firewall at my router, which has some configuration I'll get to, which only allows Cloudflare requests to come in. I have good subnetting where I've separated all of my devices. I have a home, some home automation stuff going on, mostly just these fancy lights that kind of connect to your Wi-Fi. And I have my workstation PC and my laptop, which connects to another subnet. And then finally the server, which connects to a separate subnet, right? So doing this kind of keeps it separate, and you know that if something gets compromised, the others won't kind of fall into that. So this is one way to expose your service to public. And I'll get some more details on this one. So yeah, network segmentation via subnetting, right? try to keep it separate, firewall, and conditional port forwarding. So conditional port forwarding, where you have Cloudflare's IP ranges, which you can configure on your router. If you have something like pfSense, it's really easy to do. You can do it on UDP and just configure that if some hacker finds out what your IP address is and he wants to connect you directly, he won't be able to get in because you only allow requests to come in through Cloudflare's DNS, right? So that's like pretty cool. And all of this for free. You don't pay for it. There is also a way to reverse tunnel through Cloudflare tunnels, but I did not find that quite intuitive, mostly because they have restrictions on what you could serve, right? And yeah, you would want to have all your DNS on Cloudflare, gives you all that good security stuff. You want to have an IDS and IPS system for alerting, logging, and even maybe have alerting, logging, and blocking, like UWF does, and fail to ban do good. But if you want to have something on your router level, you could, if you have pfSense or OpenWRT, you could go ahead and do that. Finally, you have your internal reverse proxy. In my case, it's Nginx reverse proxy, which is configured to a certain set of domains and then gets routed to a certain set of ports, which again connects to Docker ports, right? So downtime. Downtime, pretty much, regular maintenance. We would want to just do your apt-get updates and just keep checking your monitoring tools with the IDP, IPS. Just have your security patches up. You could probably do this like a weekly thing where you just take care of it. Your temperature management has to be taken care of. Invest in a good heat sink and avoid any thermal shutdowns. Power management, I believe UPS goes without saying. Most of us have invested in a UPS after the pandemic. So that as well. This part is sort of like a personal experience, right? Try to get a silent server, else be ready for it to get unplugged. So this happened with me. My housemaid, Savitri comes in the morning and she's like, he forgot to turn off the server, okay? And she just plugs it off, right? And goes, and if you're doing any data restoration, if you have a ClickHouse server like me, you don't want that. So invest in something which is silent, invest in a good fan, have it a whisper quiet serverless to, accidentally be turned off. And obviously if you have parents over, they're going to complain about the noise as well. So invest in a silent server. So use cases I find really interesting these days is I'm trying to build an LLM, an offline LLM with a vector database to train some of my private PDFs. I have a lot of PDFs which I've never got to, but I like to get some insights out of it because I know on the internet you wouldn't get the same insight from these PDFs, right? So I'm trying to do that. I'm trying to do that with not a very big LLM. I'm trying to do that with something which can run on a CPU. Apparently, there are a lot of LLMs that you could download on huggingface.com. I found one. I'll get to that in a bit. A remote development code server, pretty cool if you want to just see how to, if you have something quickly to kind of check and code something, you could always log in from your browser and stuff. That's pretty cool. You can self-host your Discord, Telegram, Alexa bots. You don't have to use a Lambda or something of that sort. You can do it at your home. A Plex media server, a self-Zoom alternative like Jitsi and Jibri. I had good luck with Jitsi. I couldn't get working. The recording bit wasn't working, but I'm going to take some notes from GeekyAnts because they have something else alternative for this one. And I use Borg backup. It's pretty cool to get a site-to-site backup. I'll get to that in a bit. I have a ClickHouse server. I use Metabase for some of the stuff I do. I try to pull things into ClickHouse and connect to Metabase to just get some quick insights. So this offline LLM I found on Hugging Face, it's called La Mini LM mode. It's a pretty lightweight LLM that can run on CPU, and it's even more faster if you have some sort of a decent GPU. ChromaDB, which is an open source vector database which can connect and store all your embeddings that you get your PDFs trained on, and LangChain finally to kind of build that chat UI, right? So this is something I'm working on, pretty cool stuff. And for demo, I think I have a minute for demo. So for demo, I just have my Portainer running to Tailscale. I'm just going to take you through and show you how easy it is to navigate. People, if you haven't used Portainer, Just try it out. It's amazing. So yeah, let me just quickly. So I've connected my machine to Tailscale here, and this is my home lab server running Potena. I have 4 stacks running. I'm running a full ERP system called ERP Next for one of my family friends, and he's been. I have a backup that goes to an S3 bucket every week, so that's pretty easy to set up. All that on Docker. Um, I keep experimenting with different stacks. I keep deleting them. So this is what I have right now. And it's pretty easy to kind of just go through your containers and see what's happening. You can do some cleanup tasks here. Obviously, on terminal, you would forget, but here visually you can just see and just get rid of these images that you don't need, just keep things clean. You can attach volumes and stuff, quite intuitive. You can assign users, you have private Docker registries that you can go with, tons of stuff, right? And this is a community version. I believe the business version has much more bells and whistles. Now that's the Docker containerization bit of it, and this is what Nginx proxy looks like. A really nice UI, just what it's supposed to do. You can have your SSL certificates here. It connects to Cloudflare and other DNS if you want to, do a DNS challenge here. That's pretty cool. And adding a proxy host is also quite easy. You can add a redirect stream. Everything, all kinds of stuff works. It's as easy as just putting stuff in this input box and it just works. For here instance, I have one of my domains, which is publicly hosted, which actually goes to port 660, yeah, 606004, and it connects to this domain. All of this is happening through Cloudflare and my home lab server, right? So you can do it. So obviously you wouldn't want a lot of people to visit your stuff. This is for you, and you can go ahead and do that. I also have you monitor Uptime Kuma that I monitor some stuff with. These are just some of the services that I've exposed. An ERP Next for one of my family friends, which just works out of the blue, just without any issues and stuff. And yeah, that's mostly it. I will take questions later in the panel if you guys have any questions. So thanks.
That was a pretty interesting talk, right? So probably that would have given you a bit more insight into what all things that you would be encountering while building your own home lab, or you got a bit of inspiration to build lab, right? So saying that, now we'll be having a brief 20-minute break, right? There are a few snacks over here. You can just go have some snacks, network around, and we'll assemble back at 4:20 and we'll continue. All right. So yeah, welcome back. Right. Pro- Hope you had all the refreshments, got a break. Right. So to start the second session off, we'll be talking about how you can secure your web applications. Right. So as even Srinivas mentioned, there are a lot of things that can go wrong when you're putting anything on a public network, right, on the internet. So the next talk is mostly focused on how you could make your web application a bit more secure. One of the most easy things that you could do, probably a half an hour to 2 hours of tech debt for any of you guys, developers out there, right? So this could give you an extra layer of security. Right? So we'll be welcoming Kuldeep. So he'll be taking us through how you can secure your front end. Right? Thank you.
Hi everyone. Hello. I'm audible? कैसे था चाय? How was the tea? Cool. So today we'll be talking about securing front end. Mostly when we talk about security, right? हम लोग बोलते हैं कि is it cool with English? Cool, right? So whenever we talk about the security thing, we only talk about, mostly what I have seen is we talk about like, putting firewalls and stuff like that, making network security things and blah, 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 right? But one of the basic things that we can do to make the front end secure, for example, how many of you are front end developers here? Oh, lot of. Sorry, I'm apologizing the initially as well. How many of you are backend and cloud? Okay. I mean, so yeah, backend guys, I think they can relate to me. We always have a saying. We say that never trust anything that is coming from the front end, right? And we know front end is like, something. It is very it can be manipulated in general, right? And that's what we want to avoid, right? The real question is, we are not here to bitch about why front end is not secure. We are here to talk about how can we make it, how what can we do in general to make sure that at least we can say with some sense that okay, our front end application is a bit more secure in general than it was earlier. But yeah, again, we will still won't touch the front end. But yeah, bit about me. I'm Kuldeep. I'm a lead software engineer at STGI. I am a full stack developer, and today we'll be talking about those things in the next couple of minutes in general. Right? Yeah, front end. We don't we never trust it, and we should never, right? Why should we? We are the backend guys. So how can we make it more trustworthy? We talk about when we talk about like securing our whole infra in general. We have a lot of parameters that come into picture, right? Right from making sure that we have the right like routing table configured, we have the right set of ports available, open, the right set of ports that are closed in general, right? Like sort of trapping is coming into infrastructure and all, right? But uh, one of the things that is consuming our infrastructure is also the front end application that we build, right? That is also hitting our back end infrastructure or our cloud infrastructure. And whenever we code in the backend, from the backend perspective, we say that, I mean, yeah, just don't touch it, right? We do everything from scratch, and we say that we do all those sorts of validations and stuff like that. So after this session, it won't be like that you will have to remove those validations. I mean, we should not remove those validations. It is just that so that we can say, I mean, these things are something that like the security folks, for example, if you're going for auditing and stuff like that, they like those things more. They're like, okay, you should have those like those A plus thing grading in your application and all, right? So yeah. So, any ideas? How can we secure front end? Just couple of ideas. From we have a lot of front end folks, right? So, yeah, validations. What kind of validations in the backend? Huh. Okay, cool. Okay. Anyone else? Course. Course will just ensure that, I mean, we are accepting requests, right? Anyone else? Yeah. Pardon? Yeah, that is something that we'll have to do by default. Without it, we cannot make APIs, right? I don't think we have much options there, right? I mean, we can't distribute hardware to everyone in general. That will be like very financial thing, right? And the financial department won't approve. So okay, so we'll be talking about basic things, as we said. Validating input is one of them. Escaping output, and then security headers and all. Then we have content security policy thing, and then we have clickjacking prevention and stuff like that. We have cost policy, we have CSRF, and then we also have permissions policy, right? So these are not the only things that we can do. These are some of the basic ones that is very common and that we can think of when we are trying when we are talking about preventing making the front end secure in general, right? But today's focus will mostly be around three things that we'll be talking about mostly. How can we use HTTP security headers, how can we define permissions policy, and CSP headers, right? These three things are something that ensures that at least the whatever code is that is getting executed in the browser, right, it is a bit more trustworthy. And why is it so? We'll deep dive into it later in the coming slides, right? So, example, how we just we make applications and all, right? How many of you are aware about phishing? Phishing, phishing, not the fishing, phishing. Right. So what happens in phishing is either what they do is they make similar pages as that is very look alike. Then there's very similar as our platform, and then they you might have seen very a lot of such WhatsApp messages that claims that okay, just click this link and you will get 100 rupees recharge in your system, right? Yeah, don't click it, it is phishing, right? So why I'm talking about it is that is not the only way of phishing. What sometimes what people do is they will just iframe. We all understand about iframe, right? They will just iframe your website and we are developer, we know whatever is happening inside the iframe, we can definitely control every bits and pieces of it, right? So what they can do is they can just put the exact they can just iframe your whole website, and they can spin it around, and they can share it, circulate it in the whole global, and anyone who is accessing it via your website, they can those whose data is in a way is exposed to the hacker in general, right? So why it is there? Because thing is how do we prevent this, right? I mean, we don't have to do a lot of things. The thing is the folks are very, very intelligent, and we have around in the web 2 world, we are I think around 15-20 years already, right? So they have already found the solutions. The solutions are those things are something that we probably are either not aware or just we don't do it, either because we are lazy or just the cloud team does not respond to our queries, right? So thing is with these proper HTTP security headers, what we can do is we can prevent all those basic things in general. For example, how many of you are aware that we can prevent this iframing thing just with, I mean, it is in our control. Were you aware? Like we can control this. Who can iframe me or who cannot iframe me, right? So, for example, that's what these headers are totally about in general. Like security strict transport security ensures that we are doing we are doing communication in HTTPS only, and then we also have X content type options in general. What it ensures is that whatever, for example, if you are trying to load an JavaScript file, right? The content type of that file should be JavaScript. It should not be text or something like that. For example, I'm not sure if you are aware how the tracking system works. I mean, how the analytics things work in general, right? So what they do is in order to avoid a lot of ad blockers, what they do is that cheekingly they make an API call, and surprisingly, it is not an API call. It does not look like an API call, but it looks more like that you are trying to load an image, and everyone allows loading image from any source, right? And that's how they are trying to load. I mean, if you just copy that URL, and if you paste it in the browser, you will just see a very small pixel of dot that I myself have tested it with Facebook analytics or Google analytics and stuff like that. I mean, this is a pretty standard thing that they do, right? So how can we for example, how can we ensure that no one is doing that thing with our site with our application engine, right? So we can ensure those things from here. We can define who can iframe us with the xframe options. I can say, okay, that that the websites of the same origin, they can probably they can iframe me, or the website that no one can iframe me in general, basically, right? Likewise, we have cross-site scripting. We have accesses, right? We can have some prevention of it in the front end itself, so that if you see, if you remember, initially we talked about escaping output, right? So that's what it does in general. It helps us in doing those things. And again, access control, allow origin thing, right? So I mean, these are some of the basic headers that probably if we add those headers in our in our front end application, it will probably make our job easier in general. I mean, it will strengthen the security of the front end application in general, right? Likewise, we also have the permissions policy thing. How many of how many of you actually set permissions policy right now in your front end applications? Permissions policy. Okay, cool. So let's take an example, right? For example, when we say front end is not trustworthy, right? Why do we say it? Because anyone can just open the console, and then in the console they can write any JavaScript and it will just run. I mean, I can do anything literally, right? So what, for example, if you say nowadays the web applications are smart enough that they take permissions for cameras, for microphones, and a lot of other stuff as well, right? So thing is, if you don't have a proper check in place, if you don't have proper proper rules in place, so that what anyone can do is they can simply just open the console of any of the website and they can just run some simple JavaScript. And anyway, JavaScript is anyway visible, right? They can look at the source code and they can do some sneaky thing as well, right? So what we do is, for those permissions thing, right, we define a permissions policy thing, right? For example, we say, if this is the permission that the browser gives me, so these are the sources, these are the only sources that can consume me. For example, what we do is also we integrate third party systems in our applications, right? And we use a lot of widgets, we use a lot of libraries and frameworks and stuff like that, so that we can implement those things, right? Now thing is that behind the bar, behind the name of that particular plugin, anyone can just use it to repurpose it for their personal goals and all, right? So we can prevent all those things with this permissions policy header. It is time consuming initially. It is one time setup sort of thing, but it helps us defining those permissions on a very very minute level. For example, I can say that, okay, if the camera is something that I'm going to use, then this is the only plugin that can use it, this is the only source that can use it, and no other source can use it. I can also say that any source that originates apart from my domain should be discarded. They should not be allowed. I should be the only one who should be allowed to do those things, right? So yeah, I mean, this is how we define it. We just have to define a permissions policy response headers in the HTTP response, and it totally relies on the browser, right? The thing is, the reason why I'm saying that, okay, it's not like you just put rules out there and it will automatically follow it. We are behind the assumption that the browser will strictly follow it. And any good browser, for you pick it, any good browser, like be it Mozilla, be it Firefox, be it Chrome, they respect this headers in general. So if in the headers, if I said this permission, this source should not be allowed, then they will make sure that those source are not allowed, even if you try to run the code from console and all. So it standards us, it basically gives us a but hope that probably my front end application is a bit more secure in general. And apart from it, I also have one content security policy header. How many of you have said it or heard about it? Right. So what happens in content security policy header is, it is something, it is more like a dictionary of whatever things that I'm gonna have in my front end side. So I have to define in my content security policy header. What I do is I define very minute things. For example, if I'm loading a JavaScript, I have to define in the response header itself that these are the only valid sources from where I can from where I can pull up the JavaScript files or CSS files or images, or we also have a very flexibility of controlling whatever we can load inside an iframe as well, right? So what I can do is I don't have to uh, so that no one no one just copies the code from a console and does anything wrong. I just have to define things there. So for example, a lot of time what people a lot of hackers, what they try to do is they will that is the first one. I mean, we also have tried it at some point of time as a developer as well, right? So we can prevent all those things in general, because the browser is going to respect the response header that we are going to put, and it will make sure that anything that is getting loaded apart from what is mentioned in the rule, it is it is strictly followed in general, right? So yeah, I mean that's how we so we can even tell what are the end API, what are the what are the endpoints API calls that we can make, and what kind of API calls that we can make to a certain set of endpoints as well, right? Making sure that our front end is only making API calls to the intended sources that we want it to make API calls, right? So now, I mean, we talked about these things, right? Now the bigger question is how do I make these headers in general, right? I mean, how do I find which values to put in which headers and all, right? I mean, is it rocket science? No, it is not a rocket science. It is a laborious work, I would say. So let's see how we can how what approach which I followed in my company. I mean, what happened was we had some business clients in general, and they had hired some of the security consulting company, and they were behind me. I mean, I was the cloud guy, and they were behind me. They were like, okay, you have to block the patch call to. I mean, it was a simple static application. Still, they were insisting that I in a simple static application, they were insisting that I block put and patch and delete calls and stuff like that. And they were, I mean, yeah, you understand, and they have to justify this their consulting charges as well, right? So when they were behind man, and took a lot of time. So we went to a ethical hacking company, and we said, okay man, tell us everything that they might ask so that we can implement those things in general, right? So I will tell what approach did I take, and how did I make sure that my the website of the web application of my company is actually A plus secure, so that next time they don't come and shoot arrows at me in general, right? So for example, it depends. It totally starts from the kind of header that I want to implement, right? For example, each of these headers, they have a specific use case, right? For example, if I say X frame options, it has a very specific use case. It means that what are the sources which I should allow, what are the sources which can basically iframe me in general, right? I mean, it is a more like yes, no. That's why I said, right? It is not a rocket science. It is more like a laborious work. We have to separate the cloud team, and you just have to make a list, and then you have to get it done. Once it is done, unless and until you are rapidly changing your JavaScript and CSS file again and again, I mean, you don't have to do a lot of work. Once it is set, yeah, I mean, mostly you're done, or you won't have to revisit it again in general, unless you are doing some very big very major changes in your application, right? So likewise, for example, if I say about permissions policy, right? So I know what kind of permission that my application will be using. For example, if I'm going to use the location from the user, I know I know that I'm going to use the location data from the browser's API call, and I know the if I'm using any of the third API libraries, they probably might have a documentation of how you can update your permissions policy header as well. Most of the, for example, if you integrate any of the video libraries, let's say Agora and stuff like that, which typically requires those sort of thing, they already have a documentation of how you can include their sources and all. I mean, they will just say, okay, just copy this thing and just add it in your header and it will just work, right? So again, depending on the use case, we might already have an idea that probably we are going to use it in that particular place, so we can just edit there and we can use it, right? So in my case, what happened was the front end was not very cooperative. So I had to take a hard approach. I just added a rule in the CloudFront distribution. I said disallow all, and then I started looking for the console logs. And in the console logs, it gives you very good information, right? Okay, that you cannot load JavaScript from this source because it is not listed there. Okay. So now I'm like, okay, I just copy it and then I update it in the header. Now I'm checking again. I mean, as I said again, it is a laborious work. You have to spend a lot of time initially, but once you are done, it is good in general, right? Likewise, same goes for the content security policy as well. Permissions policy header is something that is again it is something that is doable, but the CSP, the content security policy header is something that is very laborious task. Reason why I'm saying this, because if you have integrated a lot of third-party systems, you don't know what API calls, what are the sources from where they're trying to load the JavaScript or CSS, or what are the endpoints from there they're trying to load the images or making API calls and stuff like that, right? So it takes a lot of time. You have to sit with, if you have a QA team, it is good. I mean, what I used to do was I just updated it, and then I parceled my work to QA team. Okay, now tell me I just told them, okay, just you have to look in the console logs in this manner, and just give me the error list so that I can do it deployment and on a cron basis, like on an hourly basis, and they can figure it out in general. So that is one approach that you can also take. There are two approaches. Either you can go with the hard way that I went with, or you can sit with the front end folks and start documenting in a Confluence doc. Okay, these are the API calls. If you have needed any third party system, oh man, let's just whatever things your API, whatever things your third library calls, right? And then from there we can also do it in general. So these are like some of the common approaches that we can do in general. Now how do we set those response headers, right? I mean, we know how to define it, how to calculate it. Now how do we like set those response headers in general, right? So it mostly relies on two things. First of all, it as I said, it is essential to understand how it is deployed in general. The reason being is it is not a backend server. We have to understand it, right? In the backend server, what happens is we have the control of in the API call itself. We have the control of the response address in the API call itself. I can just make a middleware and make my server respond some of the predefined response address, and it will just work fine. But it is not the backend thing, right? It is front end. It is a static thing, and it does not compute on the go, right? So there are some headers that can be added in the HTML tag as well. I mean, we have meta tags in HTML, right? So we have an option to either add those tags there itself. I mean, there are some tags. For example, content security policy tag. The header is something that can also be defined as a meta tag, right? So if that is possible, you can define on the HTML code itself, so that we also have a source of truth as well, right? I mean, we can just by looking at the header, we can say that okay, these are the sources from where we try to load contents and stuff like that. But if you don't want to do that, we also have several other options. As I said, if you're going with cloud, right? If you're going with cloud, let's say if you're using any of the CDN, right? Usually, because that is a good configuration that we either go with Netlify or we go with S3 plus Cloudflare or CloudFront distribution, right? So in those cloud distributions, or the cloud service provider that you're trying to use, usually they give an option of I mean, they're intelligent, they have been there, right? Some engineer might have scolded them, "Oh, we want to add this, give us an option," right? So they already have those options available. Most of the mature platforms already have these options that can be configured as well. So if you go with, for example, if you go with CloudFront, right? In CloudFront, we have a policy itself. I mean, we have a policy where we can define whole set of response areas that we can attach with our CloudFront distribution. So any API call that you any of the render that that goes by the CloudFront distribution, that they will already have those headers and all, right? If you're not going via that, if you're not using any of the cloud providers, I mean, not using any of the cloud providing services like CloudFront, Netlify, and stuff like that, we either go with the simplest approach, right? I mean, we take a EC2 machine and then we build and we put it there in behind an Nginx and stuff like that, right? So in that kind of configuration, we have to put those configuration. I mean, in that case, the job of returning the response header will be of the Nginx server. I mean, not of the static build, right? I mean, in the Nginx, I will add okay, for this location, whatever you're getting, if you're getting any of the AP call in this location, just return this set of address that I will define in general, right? And likewise, if you're going with Kubernetes already have an option to configure those things in the grace file that we define, right? I mean, we can pretty much define it there as well. So I mean, yeah, these are some things that we can do to make our front end secure. But does this mean we are going to trust the front end? No, we should not. Thanks, folks. This was my.
Thank you. Thank you. That was pretty insightful, right? So these are a few kind of things that you can probably inherit as developers, right? So adding a few response headers here and there would increase the security of your own applications by quite a huge margin, right? So that being said, so we'll be moving on to our next speaker. He is one of our in-house guys, Aditya Prakash. So he'll be presenting to you on how you could deploy any of your application stacks on micro VMs, right? Like Firecracker, Alexia, and all those things. Today he'll be talking to you about how to develop applications on Firecracker VMs, right? Thank you. Over to him.
So, am I audible, guys? Yeah. So, today I'm Aditya Prakash, and I'm Senior DevOps Engineer working here at GeekyAnts. And my topic for today will be deploying Abstract to Firecracker micro VM infrastructure. So, I'll be starting with comparison of this Firecracker micro VM infrastructure with some traditional ways of deployment. Then, how did we start working on it? What are the tools that we here at GeekyAnts use to deploy this particular infra? And how do we design the infrastructure over using Firecracker microbeams? So to begin with, let's start discussing at some of the traditional and common ways of deployment. As you know, the most usual common ways are basically a VM deployment and a container infrastructure. So as soon as, say, virtualization came into picture, the first thing we started doing was setting up small VMs onto an underlying OS system with a hypervisor layer in between to talk to the kernel of the underlying node. So this is how the infrastructure looks like. We have a hypervisor layer, and on top of it, we have various guest OS, which has its own sets of binaries and libraries, and on top of which sits our application. So it comes with some advantages. The advantages being enhanced security because of the isolation between apps and predictable performance. Though it also has some disadvantages, being improper resource utilization. How do we adhere to that? Is, say for example, this particular app 3 is not using all the resources that has been assigned to it right at the beginning. So because of which improper resource utilization will take place. And if app 1 requires some more amount of resources from the infrastructure, it cannot be transferred to it. So again, because of the guest OS present here for each of the VMs, we see a longer provisioning time. Then came in a phase where people were not so much into security, but wanted things to boot up at a faster time, wherein came the container infrastructure. So very similar to what we saw in the VM stack. We have an operating system, a container engine in between, commonly referred to as the Docker engine or the Docker daemon, on top of which sits the binaries and libraries, and on top of which sits our application. So basically, these containers that are running on our underlying node share the resources. So definitely it solves the problems of faster boot up times, but again comes with a disadvantage because of the resource sharing is less security, less isolation. And also we found out that for stateful applications, these are not giving a very good performance on production levels. Stateful application being those applications which which store our data, like the database, the Redis clusters and stuff. So then came in Firecracker. AWS introduced Firecracker back in 2018, and AWS Firecracker is the underlying concept that AWS Lambda uses. And AWS claims that they are able to handle trillions of requests for hundreds of users every month just with the help of this concept. So what basically is Firecracker? So as it's written here, Firecrackers enables you to deploy workloads in lightweight virtual machines called micro VMs, which provide enhanced security and workload isolation over traditional VMs while enabling the speed and resource efficiency of containers. So what exactly is Firecracker? It brings in best of both of the worlds. Brings in best the security features it inherits from the VM deployments and the fast boot up times from the container infrastructure. So basically, how exactly does Firecracker implements this? What Firecracker does, it takes a VM and removes all the guest level functionalities and also a few of the drivers, because of which the size drastically reduces. And this not only comes with the advantage of reduction in the size, also what we are having is we are having less surface on which the security attacks can take place. So we have faster boot up times and also secured infrastructure in which we can go ahead and deploy our applications. So let's deep dive bit into what the Firecracker infrastructure looks like. This image I've taken directly from the AWS docs. So as you see, there is a bare metal server that is our underlying node, on which sits our KVM, and on top of which, inside the user space, we have multi-tenant micro VMs. We can boot hundreds and thousands of multi-tenant micro VMs on a single particular node, similar to that of a container. Now, exactly what are the other advantages that Firecracker is providing? How does an external user or client interact with the Firecracker system? So Firecracker provides, its own RESTful APIs, which has connections with rate limiters, so that when we boot, say, a micro VM, we can, at the time of booting, we can specify the amount, the type of network on which the VM needs to go, and the amount of storage that is assigned to it. Also, with its metadata service, RESTful APIs can be able to talk to the guest OS and container workload. So as I discussed the security end of Firecracker, Firecracker enables another layer of security, that what you can see here is a jail barrier, which sits outside the virtualization barrier. Say due to some activity, some hacking activity, a person is able to break your virtualization barrier. Still, a jail barrier provides as a second line of defense to your current running infrastructure. So as I said, it has advantages over our traditional deployment methods. For example, it's lightweight and fast. Lightweight and fast as compared to the normal VM stack. It's secure as compared to the container infrastructure. And moreover, it provides us with the API-driven management to boot up micro VMs. So how did we exactly start using Firecracker micro VMs in GeekyAnts? So you can go ahead and boot the Firecracker micro VM from scratch, but there comes a tool right in the beginning which Faz discussed about OpenNebula. So we started using OpenNebula. So I'll show what OpenNebula is. OpenNebula is a powerful and an open source platform to build and manage enterprise clouds. For example, you want to have a data center of your own. You want to have different types of hypervisors. On those hypervisors, the micro VMs, or say, for example, the VMs that you are booting, you want to have granular control over each and every component, like the CPU, the storage, the type of disk that is attached, or even the type of network. Everything can be properly managed with the libraries OpenNebula provides. It's very easy to install. You can go ahead and install it using yum or apt-get based on the operating system you have been working on. So let's have a quick overview of how the OpenNebula structure looks like. We have an OpenNebula infrastructure, which allows us to have shared networking and storage resources for all the VMs that we are booting. It has availability of all the different kinds of popular hypervisors, be it a LXC, KVM, or Firecrackers. If you don't want manual process, it has its own providers given by Terraform, Kubernetes, Ansible, and Docker. Entire process of booting of the architecture can be taken place with the providers that Terraform and Ansible provides. There is only one built-in tool that's given here. We'll go into deeper context into this as to what are the key components OpenNebula is providing us. So let's start discussing that. OpenNebula Sunstone. OpenNebula Sunstone is nothing, but a web-based management UI for us. It gives us anything and everything that we need on our infrastructure. We can manage everything right from the data center to everything down to the micro VM. Say, for example, you need a network system just for your micro VMs. You can handle it using the Sunstone GUI. You have different clusters, say a cluster in India, another one in Germany, another one in somewhere else part of the world. You can handle all the data centers and clusters using OpenNebula Sunstone. Uh, or you can have networking modifications right at the data center level as well using OpenNebula Sunstone. OpenNebula FireEdge is nothing but an advanced version of the Sunstone GUI. Again, comes in with features where we can provision OpenNebula clusters. Then comes in OpenNebula Gate. The one gate server, say, whatever information right at the beginning to boot up small micro VMs are present on the 1D master node. How do we distribute it to different nodes? How do micro VMs take up that information and boot up on all the different underlying nodes? This is done with the help of OpenNebula Gate. And OpenNebula Flow is a smart tool which helps us start and stop micro VMs on the OpenNebula infrastructure. If having a confusion, you can take an example. Underlying system is very similar to any other container orchestration tool like, say, Docker Swarm or Kubernetes, wherein you have a master node. You can go ahead and keep attaching small and various nodes to it, keep increasing your cluster size, and OpenNebula master, the 1D master, will be smart enough to distribute the load of all the micro VMs across all nodes. So the key components of Sunstone, as I discussed, you can have any and every type of virtual network setup on the micro VM using the Sunstone. The storage tab is where you define whether you keep your OS images, you keep your Docker containers, Docker image, path of Docker images, volatile and non-volatile disks. Templates are what you can do is you can create customizable templates. Say every time you don't want to boot a VM right from scratch. So you can have ready to go templates, and using those templates, you can go ahead and boot micro VMs. And instances is something where all this information gets aggregated to boot a VM. And dashboard is something what you see is all the information about the current running cluster on this particular UI. How OpenNebula has helped us at GeekyAnts. I mean, let's shift the topic a bit out from Firecracker. Right now at GeekyAnts, we have set up our own data center. And because an OpenNebula has helped us a lot, we have a series of big underlying machines, and on top of which we are, say, running 50, 60 UAT and QA level projects of the clients we serve. So, and it has also proved to be very cost effective for us, because until the last quarter, what we were doing is we were buying provisioned servers from various cloud providers, mostly Hetzner. So right now, just with the one-time setup, we are able to completely remove that monthly cost. Also, it has been a huge learning experience for us. Immense granular control is something that I said earlier is what OpenNebula is providing us, right from the OS image to the networking to the entire cluster. And lastly, say, because I said we are running a lot of projects of clients, so OpenNebula solved a very big problem for us. It provides its own billing component, because of which we just need to set the stats and we can go ahead with it. Now, the main part of the talk. How did we design a basic infrastructure? This is a very high-level diagram. I'll go deeper into it in the forthcoming slides. See, for example, an internet, and we have a proxy server present here. The entire communication of all the application stacks that are present inside the OpenNebula infrastructure goes via this particular proxy server. And this is a proxy server which points a wildcard on a domain mapping of a wildcard on, say, any of the DNS providers we use, be it Cloudflare. And this is a health monitoring service. This is the USP of this particular architecture. I'll discuss in detail about it later. So external proxy server. I would like you guys to pay attention to the various networking interfaces that we have attached. With these basic networking interfaces, we are able to, bring in security to our application. So the proxy server, first of all, it's just a proxy server. Say, for example, Nginx is something, external Nginx, and this is something that talks to the internet. So this needs to be a bare minimum server with bare minimum specs. Say, for example, a T2 Micro on AWS, something similar to that. Because it only has Nginx running onto it, it has a public IP with which it talks to the internet, and then network NIC card 1 with which it talks to the underlying application stacks. Let us look at the internal application stack design. So externally, we have one service router. Service router is the entry point for each and every application stack that is running on OpenNebula. It has two network cards attached to it, NIC1 and NIC2. And all the other applications cannot be accessed anywhere outside, because of only internal communication happening only with the service router using NIC2 network card. And all the log aggregation is something that is going on to the service router, where we collect it for monitoring and analytics purpose. So understanding the components of the service router, before I jump to service router, I would like to say that OpenNebula itself provides its own service routers. If you just need, a basic networking entry point to your application stack, you don't need a custom solution for this. You can use something that is by default provided by OpenNebula. But actually, we needed some custom solutions to run on our service router, because of which we had to build our custom one. So first of all, this has the Nginx, the main Nginx component, wherein the server name will be the fully qualified domain name of the entire application stack. As I said earlier, we wanted logging. So we had set up a basic logger app which collects data from all the underlying stateless and stateful application. This acts as an internet gateway to the entire application stack, because of which we are able to understand the network bandwidth consumption and help us understand network chokes or issues that are coming up. Next, we discuss this and how to boot stateless applications. So you might be thinking how to boot stateless applications. Stateless applications are your front end and back end applications, basically your code. So not much effort to be put there. At boot time, just specify the Docker image, specify the networking, specify the amount of storage and the networking you want to attach. Within few seconds, your micro VM will be fired up. Then comes how to set up stateful applications, your databases and stuff. For this, maybe I won't recommend going ahead with, say, Docker. You can, again, similar to a router, keep templates available for different databases. Say for a MongoDB, you have a separate template. For Postgres, you have a separate one. And for, say, MySQL or Redis cluster, you have a separate one. So using those templates, you can fire up stateful applications. And here you go. You have an entire application stack booted up. Let's quickly jump back to the health monitoring service, which I was discussing, as to why do we do that? Because see, if you mask this particular point, the health monitoring service, this looks very simple to maybe say a Kubernetes cluster or any random load balancer involved application stack. So basically what this health monitoring service does, we took the idea from fly.io and tried to develop something of our own. And this is still a work in progress for us, guys. So this is one of the most exciting features of our infrastructure. What this does is, say, for example, you have 3 application stacks running here. And the application stack 3 is something that you maybe use once a month, or maybe you don't use it much, or it has gone into dormant state. But somehow, due to some decision making, you don't want to remove this application stack from your infrastructure. So what health monitoring service will do, it will monitor the amount of traffic that is being received by this particular application stack, and it will simply go ahead and power off all the micro VMs. So the advantage of this is, when you power off, it will release all its resources, and these resources can be used by some other application stack, improving the health of your system. And say for the next time you want to boot a new application, or you just want to power on this, these are very small firecracker micro VMs. Within seconds, you'll have the application stack up and running. Also, this is we still haven't moved to that part, but this is the service where we'll be running our scale in and scale out policies. As to, based on the incoming traffic, we'll scale out the number of instances of one particular application stack. So I believe in the forthcoming days, my firecracker micro VMs will be something that, completely overpower the container infrastructure and the VM deployments. And I would recommend not to move into production with this as of now, because we ourselves are in the QA and UAT, deploying QA and UAT and pre-prod projects of our clients on this. And we'll be happy to collaborate if you start working on this. Thanks a lot, everyone. Yeah.
Anyway, we have panel discussion right now, so we can take up questions over there. So, thank you. So that probably give you a whole idea over here, right? So in a few minutes, we'll be starting our panel discussion. So over here, we'll be taking up any of your questions that you've noted down till now, right? So let's keep it a very interactive session. So what all the questions that you have to our speakers, you can start firing it up now, right? So we'll be starting the session in the next 5 minutes, right? You can probably take a bio break or something and be back, right? Okay, na? So on the third part, right, so we'll be taking up any of the questions that you had, any discussion points that you wanted to ask to our speakers, right? So again, to give you back a recap introduction, we have Srinivas over here, we have Kuldeep, we have Aditya, and we have Robin, right? So any of the questions that you have that you have noted down throughout the talk, probably this is the best time to start off with, right? Okay. Do you have any questions? Well,
Yeah, the micro VMs thing. Correct me if I'm wrong here. From your talk, right? My understanding of what this Open Nebula thing is that it's like a hypervisor where you can use it to spin up VMs, micro VMs, and also containers, right? So it's kind of like an all-in-one solution that does everything, like that handles like containerized containers, VMs, and micro VMs. Is it that? I just wanted to understand that.
Yeah, it's actually that. It provides an end-to-end solution to
Okay.
any kind of hypervisor you want to use on top of your underlying node cluster.
Okay. So it's kind of like Docker desktop, but like on steroids.
Yeah, something similar, but
Yeah.
it's more manageable
Yeah,
because
okay.
we can handle everything right from the networking to storage to
Okay.
CPUs from there.
Does it also handle orchestration? Like, does it like if you like spinning up more containers depending upon your load and everything? Does it also do that, or
It does not.
so it doesn't handle? So how would you use it for? So because that was my one question, right? Is from everything you said, it's good for like a data center type thing where you have like clients and there's only like one instance, you're never going to see load. But if there is load, how would Open Nebula be useful if you see load?
Okay, so to answer that, I have a few points. First of all, because of the fact that you are using micro VMs, so readily we don't move micro VMs over to different nodes that readily as compared to containers. Also, because of this particular problem of Open Nebula itself, because first of all, with Open Nebula, we were solving our data center issues. When it comes to handling node, because of which we have developed our health monitoring service, a custom application, which will in turn go ahead and do it. Also, it is something like, for example, there is a micro VM that is not using the underlying nodes resources. So we can go ahead and increase the burst, and accordingly, those things will be handled.
So is an Open Nebula specifically built to handle, say, micro VMs, or is it like a more general thing where it can handle everything? Because
not only for micro VMs, for any VM infrastructure is
Okay.
what we can use Open Nebula for.
Okay, so it can, if configured, handle what the word orchestration even for like containers and stuff as
Yeah,
well.
I mean, we
Okay.
haven't explored that field particularly,
Okay.
but it should, because what we saw, it provides Kubernetes providers as well.
Okay, yeah, that's it. Thank you.
So
Just to add to what he said, I think the most commonly aware comparison of this would be OpenStack, right? And in terms of orchestration, I think the more appropriate keyword here would be scheduling of your or provisioning of your workloads rather, and unless it's LXC containers or something like that.
So to come up with a very brief thing, right? It's like on your smaller setups, you would rather use Proxmox to run your Alexa containers, right? So it is more of an enterprise solution on the same ideology, right? So you go to your AWS dashboards, you have EC2 and all those things, right? You go there, you give a few parameters and you spin up a VM, right? Open Nebula will give you the exact same kind of functionality, right? It will give you options to run multiple hypervisors on how you can spin up. It's more of a management thing. So it doesn't give you a lot of things in terms of scalability and all those things for your particular application. That is something that you can probably work around. There are a few things called as service templates, right? We were talking about micro VM templates, right? VM templates that you can boot up. There is also one particular thing that you can use. It's called as service template, where you can go ahead and define a lot of replica sets and all those things. Right? That is where the orchestration thing comes up. But that is a very high level feature of OpenNebula. A lot of things that are still in beta. Right? But that, yeah, as I said, that is a particular possibility.
Yeah, hi. Hi, this is Amar here. Yeah, so my question is to Aditya. Have you explored OpenStack as well? Because that is also open source like platform.
We had that in mind, but what happened is initially we shifted to OpenNebula and solutions started flowing in for us.
Okay.
So we haven't completely shifted to OpenStack as of now.
Because that's like pretty mature. It's
Yeah.
almost, I think so, 10 years into maturity in open source.
Okay.
You can also check how is the support for, I'm not sure about Firecracker, but it does do container and VM for
Yeah,
sure.
yeah, it does. Yeah, thank you so much.
OpenStack. So probably our ideology was a bit more smaller, right? So we started using something known as Fire Ignite, which is a small CLI tool that you get. You can just boot up, you use that CLI and boot up a Firecracker VM based on a OCI image, right? That is where we started. So OpenNebula was a natural increment for us. OpenShift is something that, yeah, as I said, we would go ahead and to explore. Yes, exactly. And also one of our main ideologies behind using OpenNebula was it was backed by VMware. Right? So that was one of the major things that which gave us the kind of trust that we needed to start build something. No, they actually back
No. What I'm saying is VMware is rival to OpenStack. So they compete with OpenStack. So I'm just setting the context. I've been in this space for more than 10 years. Yeah. Thank you.
Yeah, probably that is something that we'll
Yeah.
explore next. Okay. We have any other questions?
Hi, my question is regarding that.
To kind of interject here. But yeah, I was really interested about the billing aspect you said, right? A lot of my friends run an agency. Running something like this, and how do you kind of manage the billing? Like, let's say you have a UAT server and you have some sort of a server that you're using for a particular client. And like Amazon has like T1, T2 and stuff. What do you have some compute units that you kind of assign and say this is what it's going to cost? Okay.
I mean, we have a specific costing, say, for example, 2 vCPU and 8 GB server is something we are providing. So we have set up the cost metrics. And whenever we boot a VM using that template, so at, say, end of the month, it gives us with an entire report for the total cost that would have arisen for that particular VM, and we cost the client accordingly. Okay. Okay, so maybe we haven't, we still have to do that. Support if it's a downtime and a client comes up with that issue. Something we'll have to think about. Yes.
Ideally, yes, we would account for all the downtime. So mostly the billing aspect would go into the CPU time that is being used, right? So if there is a downtime, yes, that is something that we will account for. And since, as you said, right, in the stock, it is still in Q and UAT. That is not something that we have explored a lot into right now.
So say because earlier we had because we at the end we wanted something similar infrastructure. I was talking to Robin about the same. So earlier we shifted to Knative for this, and usually when we cost someone for the VM infrastructure, we cost them over the CPU, the storage disk, and the network bandwidth. So when it comes to Knative, we were trying to get those stats right from the pod level. So we were able to get the storage and the CPU things right from there. But network inflow and outflow was something that was a bit of a headache for us because of too much of noise data. Yeah, so too much of noise was present into that data. So when we shifted to OpenNebula, we saw that it provides its own billing component. So we did not have to, put our minds into how to solve that.
Probably we can shift over.
Hello. Yeah. So my question is regarding that downtime only. Like we know that Microsoft or Google has a lot of data center and they are much more reliable than OpenNebula. I'm not sure. I'm just quoting. So how reliable OpenNebula is? Like, can we rely on this?
Okay. So am I audible? Yeah. So as I just said, we haven't moved to production projects with this. We are still deploying Q and UAT environments. Right now, we haven't faced much of a downtime. But say, for example, a VM crashes and we implement the logic into our health monitoring service. It's a firecracker micro VM. So the downtime, if we are able to record it, will not be much.
Okay, thanks. And another for Kuldeep is that in like you mentioned that in front-end security we can use a CSP, which is well aware. But don't you think while implementing CSP, we are limiting our front-end where limitations where limitations putting limitation in usage of open source resources?
Sorry, did not understand. Can you please repeat it?
Yeah, like while implementing CSP, we can make our front end that from where which data need to pick, right? So don't you think we are putting a limitation?
Yeah, I mean, it is a trade-off, right? Either we can give flexibility or we can control it. So for the security thing, we always have to put restrictions over there. That is like more preferred way.
Okay, thanks.
Do we have any more questions? Nothing. I mean, everyone got the entirety of whatever they said. No one has any questions. Second one. Okay. Can you hear me till the end? You can hear me, right? Good. So you guys have no questions whatsoever. All the things. Interesting. So coming back, right? Going through all of your talks, I have a few more questions coming back. Right? To start off with, I can probably come over to you. Right? I want to know the thought process or things that when it comes to provisioning a dev environment, right? Because the first thing that strike was whenever we are building something, dev environment is the major provisioning blocker. We'll easily get approvals for your QA, UAT, pre-prod production. All these things are pretty much set. Most of the time, we are stuck with either using Docker Compose on local or something like microkit as a K3 as something that we run local, right? That is the first hurdle that we usually have whenever we provision it. So, in your journey as a tech architect, what was your thought process?
Sure, that's a great question, and you'll have to cut me off at after say 2 or 3 minutes because this is rant level material, like actually rant level material. So you'll have to cut me off in case I keep ranting on. So each team has priorities. Each company has priorities. We IoTify itself is a company in Switzerland, and it's remote, entirely remote workforce across time zones. So ours was entirely cloud based VMs, which we were using for development as well. And our project itself is microservices architecture. And each of those have database dependencies. Some are in Golang, some are in TypeScript, some are just purely front end. So we realized our advantage as a startup is trying to minimize our turnaround as much as possible. So we wanted a very quick and effective dev environment. So if there's an issue that happens, we should be able to reproduce it as fast as possible, or even if it's a feature prototype, spin up a dev environment as fast as possible, troubleshoot it in an isolated manner, and carry ahead with whatever you're doing. So say if we are working on a microservices, apart from what we are working on, we could bring up everything in Docker Compose. That is one advantage that we had. So in terms of feature development, that's that each of our environments, we just had Docker Compose. So you bring up Redis, Postgres, various other services that we had, except for whatever you're working on, everything else is available as Docker Compose, and we had the networking as similar as possible. Now you can make the argument that the networking and certain aspects of Docker Compose is different when in comparison with Kubernetes. But luckily, as far as our use case was concerned, the transporter was over Redis or something called NATS. It's an alternative to Kafka. So we didn't run into many issues there. Networking, your L4 as far as was concerned was quite simple. Another thing is in terms of, we had a sandbox environment, which was Kubernetes. So feature development on Docker Compose, and then if at all some issue came up, for example, there were issues with persistent volume claim scheduling in across several availability zones. So those got caught in sandbox environments. But then again, it's still in our control, right? And only after all of this, we basically put it to production. Does that somewhat answer your question? Or I think I might have gone off on a tangent there.
No, we quite pretty much got the idea.
Right.
So I mean, yes, your use case actually required active environment to be up and running to get all of these.
Yeah. As fast a turnaround as possible, essentially.
And a lot of times in our case scenarios, other than the IoT and the main data center related stuff, right, our main issue is basically giving out any kind of dev environment for other web applications or even a simple packet where we get a few questions saying that you can run it on local, you can run it on local. Why do you need a dev environment? Why should I pay for a dev environment?
So just to add to that, we try to make it as, let's say, separated as possible in terms of concerns. So if you want a specific version, you could just pull that tagged image from our private repository and just bring that up. So again, you're talking about like not dedicated dev environments, but like a VM isolated to your context. Yeah, it's a hybrid approach in terms of cost, I would say.
That is something similar even we are doing. And that is where his open nebula stack comes into play.
Okay.
Whenever developers come across, like even we are working remotely, right? Developers come across saying that, okay, this is not working or this might not work or my laptop is going for a toss while running this or that. And that is where we come in. Look, we need something. I mean, we'll not be paying up a lot of money for even AWS or anything to run our dev environment. That is where the entire journey of our thing started. Initially was more to provide a dev environment, which then became a whole different story altogether.
So what we have done actually, so for example, we have fixed our tech stack. That is first thing that we did. I mean, if you don't have any crazy requirement like that specifically requires a different tech stack, we don't change the tech stack. And what we have done is we have made a centralized template in our GitHub repository, right? And that is a template generator. Whatever we have to do, I mean, and we have perfected it. I mean, it is already configured with like AWS, and we use EKS and all. So everything is configured, and we also have Terraform scripts as well. So for example, let's say if I have to spin up an environment, I will just run Terraform script. I will just sync it with the task definitions, and like it will be up and running in general. That is one approach that we do. When we don't consider the cost factor, or if we consider the cost factor, then we have a Docker Compose file. We just spin up a EC2 machine and then just.
At the end of the day,
yeah.
that's
And until it breaks, it is good at running. So it is your environment, one guess. So.
I think one thing that is again, sort of like referring back to the talk that I gave, is that awareness once developers understand of what constitutes a runtime environment or a runtime context. Once developers get a good understanding of that, then some of these issues will eventually solve itself. So it could be something in your bash RC, or it could be some configuration that you set somewhere else. So it could just as well be solved by you spinning up a Ubuntu container in your machine itself, and then so I think the idea is to make it as replicable as possible.
That's it. And more interesting is your setup, right? Home lab setup, right? I mean, your home lab setup is one production environment. All the things that you're migrating, doing anything, you're basically touching your own production environment, right? Yeah. So, I mean, what is your thought process going through your experimentations, right? As you mentioned that you usually scrape off the older deployments, bring in new technology, test it.
Yeah, maybe that was the original, motivation behind doing that. That so many times you just spin off these droplets on DigitalOcean or AWS, thinking that it's free or something. Now, as a hobbyist, that is a cost to you. Now you want to get rid of that cost. It is sort of a pinch in the pocket. so many of our Netflix subscriptions just don't go away. It would be something of that sort, right?
Yes.
And so that was a motivation where, one Saturday I just decided, okay, let me just try this. And like he said, right, once you set up a home lab, it just doesn't stop from there. You just keep, same thing for you in the company, right? You have a private cloud setup right now. It wouldn't stop there. You will just keep upgrading.
Yes.
You'll just keep
exactly.
adding stuff to it and stuff. And one of the biggest motivations to have a proper setup is I was trying my hands on one of the security tools called cartography. You can look it up. It's from a company called Lyft, right? Cartography is a Python tool that has a Neo4j graph QLDB. And what it does is it pulls information from your AWS, your Kubernetes pods, your GitHub, your Nessus, your logging, everything, and starts forming these ingestion strategies to kind of link everything, right? So you know exactly what your Kubernetes stack is doing, and when you had a deployment, where if there's a downtime, you know exactly, because you can't structure this data in SQL, you can't do it in MongoDB. You need to have a GraphQL. So cartography was my motivation behind having like a proper powerful system to kind of try this out. Again, you need that kind of data to kind of experiment with that sort of stuff. So I started pulling in stuff from my own stuff, and I spin it off sometimes. And I was fortunate enough to kind of work on a very big project where cartography was being used. And that was sort of the motivation. So one of the persons who used to work with lifts, who still contributes to that repository in GitHub. So yeah, that was mostly open source kind of motivates you to kind of do such stuff. Yeah.
Just to add that there, I'm a fellow home lab enthusiast, and I've been talking a lot to Srinivas about that as well, and it really is rabbit's hole. Once you start off, it's gonna eventually. And my home lab is named Appledore. It's a Sherlock reference. So it's another AWS Appledore Web Services. So again, exposing a lot of the concepts that you would be working on your own personal time. You can understand how it would work in production. So monitoring, exposing services, firewall rules, setting up environments. We are back to there again. But a lot of those you can actually take that old laptop and then install Proxmox or KVM, or just get started somehow. It's quite empowering. You actually get to understand how DNS works. Like half of your issues are DNS related. You can set up Pi-hole, ad blocker for your entire network, right? That was quite cool. And backups. You get to think of it from an enterprise sort of aspect of it. Like for example, my website is served from my apartment, and in case my power or internet connection goes, it fails over, it gets rerouted to another Linode instance. So it's over engineering, but it's like the most beautiful form of over engineering, right? Home lab enthusiasts are the best over engineer.
Started off with a basic setup, and now as day goes by, the complication increases.
Yeah. Just start off. It'll just pull you in.
Even I'm actually a home lab enthusiast. Right?
Awesome. We should.
Even I have a setup at my home, but my setup is mostly refurbished. I don't have an extensive setup. My setup is actually running on a very old Pentium 4 system. Right, so whatever we had available, right? So that is something uses the age-old DDR2 RAMs, the 80 GB SATA hard drive. Pentium 4, for the first time they had brought in hyperthreading.
Okay.
It's
Gen
a
4
very old classic setup.
Good.
But
you get to test your stuff under resource constraints.
Yes, pretty much everything is running on that. Like we have distro, Ubuntu.
Right.
So that is the one that I use on that particular setup.
Awesome.
It's also pretty much what you call resource constraint, and also that particular system is still 32-bit.
Oh, okay. So
it's a whole new thing out there for
that's
me to.
an additional Pandora's box.
So a lot of things, right? I also have a set of Raspberry Pis where I also have Pi holes.
Awesome. We should have a home labbers meetup.
Yeah, it's actually one thing. It's actually one thing that we are looking for.
Awesome. Let's do it. I think he had it.
Yeah, you had something?
We distracted you with home lab.
My question is another micro VMs thing only. So one thing I kind of need to understand is what is like the smallest unit or a smallest entity you would consider you can deploy in a micro VM. For example, what I mean by that is you take Docker Compose, right? If you take a Docker Compose, you can basically define pretty much everything required to run your software, front end, back end, Postgres, right? Simple. So when you look at it in that terms, what would you say is like the lowest entity that a micro VM can represent?
One microservice per micro VM.
Okay, so if let's consider we have a Docker Compose file that has 3 services: a Postgres, front end, back end. So you're telling me that a micro VM can basically be front end, the back end, and maybe even can I run Postgres in a micro VM?
Yeah, you can.
Okay. All right, fine. So I read somewhere, and maybe you can enlighten me on this. Because my assumption before this talk was basically like micro VMs, you can think of them as because I was aware Lambda functions kind of run on this. My assumption was like they were more like for Lambda functions itself, where you can just spin up for like one isolated instance thing.
So again, to comment onto that, what I can say is Docker Compose. Say for example, you are using for your non-production environments, right? When you are moving into production, what you are using proper stateful managed services. So this is what you can do here as well. When you move to production, you can have dedicated servers where you can go ahead and boot your VMs. Your stateful applications. For UAT and pre-prod environments, you can still have the Postgres instance running inside your VM, micro VM.
And I have another question for Srinivas and Robin, basically, or any home labber here in general. What do you think about what's happening with Ansible and Red Hat and everything, right? Because I'm kind of certain every home labber has like the same opinion on that. I just wanted to ask.
I think it's not cool, and I think Jeff Geerling had the best reply to that. So, just for context, Jeff Geerling is very experienced and a very core contributor to the Ansible project, and he had written a definitive book on Ansible. So he open sourced his book and just said, "You guys can copy Red Hat. Hey, Red Hat, you can copy this if you want." So I think anybody working on the open source ecosystem would be a bit concerned with what happened, especially the Red Hat model, right? So I think it's good and keeps us on our toes to invest in backups and alternative distributions and always have a contingency plan. And in that way, it makes us a bit more alert. And I think it would have the community's guard up a bit when making design considerations and choices. But then again, corporate world stuff happens.
RACL, we had CentOS. After CentOS 7, they just closed down the entire open source.
Yeah, right. Yeah.
Yeah, I mean, we were just talking about it, he brought it up when we just met, and what's happening with Red Hat? I'm like, not good. But then again, I think we sort of saw this coming when IBM kind of took over. We saw that, enterprise has always mean greed and stuff. And Red Hat being like, for the longest time, they've been doing only good stuff. CentOS, and they also used to, Fedora was amazing as well. They kept contributing so much. Whatever went into Fedora got tested for a while, then that went into like Red Hat and stuff, right? So a lot of, I don't know how many of you know about OpenShift, which was also Red Hat stuff. One of the very early on, cloud solutions which you could put on your private cloud. They had this concept of cartridges and something I can't remember, which was basically compute power with RAM and CPU, where they first coined that word, right, which others kind of picked up. But now I see it's going down the drain. But I think as a good thing, OpenSUSE has recently kind of come up with a project where they're gonna kind of pick that pace up, and OpenSUSE is kind of doing some good stuff there. So yeah.
I guess.
Yeah, so I have one question to the home lab guys here. So what's the cost of your setup? because all of the people in the crowd are cloud users, just to get a context so that everyone knows how much they're paying for the cloud compute and how much does the home lab one time cost.
Yeah,
That's exactly it, right?
No, but what's your cost? Yeah, that's the point. His point is valid. I
I
know.
would rather not. I mean, I never say this. I usually say any questions about a good question, but that is a very bad question. I am. Let's just say I'm not at liberty to disclose.
That's why I got it. It's pretty expensive. So Srinivas, what's your
It
home
gets
lab
expensive
cost?
very
Yeah,
I-
pretty expensive one he has.
I think I can expose not too much. I started about spending 25 grand, and then I put another 10 grand. By the time I was done with it, I ended up spending about 40 grand. But on a good note, like home lab is expensive to set up in a certain way, but in a long run, I'll be saving a lot. So it was like a good investment.
Yeah, pretty nice.
So just to add to that, since we are recording and there might be people watching this afterwards as well, on the note of it can be as expensive as you want it to be or as cheap as you want it to be. Raspberry Pis are quite expensive these days, but Raspberry Pi alternatives or like a second-hand laptop. One of the most realistic things is like a refurbished computer you can get on Amazon refurbished, or like even if you're in Bangalore. Um,
SP Road, yeah. SP
lot
Road
of
we can get.
yeah, you can SP Road exactly. You'll get like a lot of second hand. Get something that's say above fifth generation with some DDR3, DDR4 RAM, and you can kit it out yourself. I myself started off with a Ryzen 3600 and the cheapest GPU just because I wanted to get a display output. Started off with 8 GB RAM. That 8 GB became 16. 16 became 32. Started with 512 GB of storage. That became 1 TB, then 2 TB, then 4 TB. It keeps adding. Don't worry about it. Don't think too much about it. Get started. It'll keep expanding on its own, and you won't be able to. It's a problem, guys.
It's not an upfront investment. You start off with as little as 5 or 6 thousand on a Raspberry Pi, and sometime 5, 6 years down the line, you would have end up spending anywhere around 2 to 3 lakhs across. I mean, that still would be fine. Right?
And anyways, MacBook Pro is 2 lakhs, yeah. So,
But the
just to set the
advantages.
context, yeah.
So two things to that. There's a great degree of freedom. I think yours is still your daily machine, right? So there's a certain degree of freedom that comes with having an environment you can completely wreck. I can't do that with my daily driver machine. But if it's like a dedicated machine, you can of course like try new. If you're distro hopping, you can of course distro hop. But having a separate machine or a separate hour to help with that kind of helps. Another advantage is it need not be the latest. It can be outdated, second hand. It's not critical, mission critical stuff, right? So, and Linux is very light. So.
Yeah, exactly. So yeah, I guess that would be it for today's evening. Right. Thank you guys all for joining in. Right.